Oh, hello, everybody. My name is Wim Mathews with the Oregon Department of Agriculture. I manage the confined animal feeding operation and fertilizer programs at the department. And I'm here to present the middle section of the approaches to helping CAFOs and AFOs manage manure nutrients in Washington, Oregon, and Idaho. So I wanted to start my section of the presentation with a little description about CAFO permit requirements in our state of Oregon. Uh, we define CAFOs that require permit registration at a statute 468B215, and that is a universe, creates a universe of CAFOs for us that includes all of the federally defined concentrated animal feeding operations, as well as a pretty large group of state defined, what we call confined animal feeding operations. And so, to give you a little description of the audience that my talk's going to address, is going to be those permitted CAFOs that we define in our state statute. The size of that group right now is 512 different permit registrations across the state. 369 of those are federally defined facilities on a NPDES CAFO permit, and they're in general permit registrations. Four are NPDES individual CAFO permits. Those are the group of 369 plus four. That's the total federally defined facilities. 138 are on a state permit, water pollution control facilities, general permit, and one on a water pollution control facilities individual permit. And those 139 facilities are what we call the state defined facilities. So that's the description of the universe of folks that we deliver these services to. And we also have 12 CAFO permit registrations in some sort of pending status with us right now. So those numbers should be going up a bit here shortly. So part of the goals of our program is to encourage and maintain the diversity in Oregon's permitted CAFO universe. And as an example, using dairy permits as an example, the smallest facility that we have permitted in Oregon is they're milking 3 cows, and the largest milks 28,000 cows. So you can see there's quite a large diversity in size. All of those facilities are on the same permit with the same discharge limitations. And definitely how they achieve those permit requirements and don't discharge the surface and groundwater are very different, are extremely different between those two facilities at each end of the spectrum. But that gives you an idea of the universe in a dairy example that we encourage. And so whether your waste system's is a pitchfork and a wheelbarrow, or the most highest tech, multi-million-dollar system, uh, our expectation under the permit is they're not discharging to surface and groundwater. We also want to talk about something that we're promoting, which is that CAFO is not a bad word. Confined or concentrated. I like confined a little bit better. And as an example, there's been a big increase in backyard chicken activities, and that's probably United States wide, if maybe not wider than that. Definitely because of the pandemic, a lot of folks are gardening and raising animals at home. And those animals, while they don't require a permit in our state, we don't permit 4 or 5 chickens in the backyard. We describe that facility as a CAFO. It is a confined animal feeding operation. It's just one that doesn't need a permit from us. So we want to start talking about the fact that these aren't necessarily bad things, and if they're well managed, they do a good job for the environment and all the other metrics. So all these folks that need permits here in Oregon, all types and sizes of those permits that I talked about earlier require agronomic application of crop nutrients from all sources. And every one of those permittees must develop a nutrient management plan, or in our old nomenclature was animal waste management plan, where we're now moving to just nutrient management plan. They have to prepare one of those, and they have to follow it. It's incorporated into their permit by reference. None of the plans are the same. So of those 512 facilities, they all have a unique nutrient management plan. And that talks, or that provides the management component, and I want to start using these two different buckets, if you will, a management component and a structural component about how we address compliance and assistance on these facilities. Also, all sizes and types of permits require a system, if you will, manure nutrient collection, storage, treatment, and utilization systems that have to be described. Many of them have to be engineered, and they all have to be operated and managed to deliver designed water quality protection. And so we need to have the management activity, and we need to have the structures and systems that are to be managed to deliver these water quality protections. So how do we provide oversight to our permittees and assist them with permit compliance? Well, one of the first things we do is that we inspect them fairly frequently. Our goal is to have at least one routine inspection every 10 months. So we have regular contacts with permittees to assist them with compliance. And so one of the things that inspectors do in that inspection is to review the nutrient management plan and the required records with the permittee. And so we look at, their record keeping systems, and more importantly, the data that they put in those systems. We look at decision making systems, and importantly, the data that they put into those decision making systems and what decisions those systems have spit out. And then, is the manure nutrient management system that's iterated in these data systems, is that talking to the rest of the operation? And these are all management components, data collected from the operation of all these structures and systems that are generating waste, storing waste, treating waste, and applying it, these manure nutrients, and out to the crop system. And then at these inspections, we're going to also look at manure and process wastewater storage, treatment, and application systems. And our question there as we look at these is, are these systems delivering designed water quality protections? And those are the structural components. These structural components are now starting to include things like decision-making systems. Sometimes they're saying, well, geez, I had a software failure and it caused me to get some strange numbers. And it took me a little while to realize that I had to make some changes there. So also in the CAFO inspections and oversight, periodically we'll perform targeted inspections that focus on one part of the system so we can pay more attention to that part. And these inspections are in addition to the 10-month routine inspection. And again, it's another part of our regular contact to assist with compliance with our permittees. These may be on larger facilities. These may be on facilities that are having challenges with compliance, permit compliance. These may be on facilities that are located in sensitive environmental areas like groundwater management areas. So or they could be at the request of the permittee that we come out. And inspectors on one of these type of inspections may review and focus on things like fall soil nitrate samples, the results of those, soil P and K levels, soil moisture levels, crop yields and quality. And the questions that we're asking and things we're looking for is, are these sample results and this data that they collected, is that talking back to the nutrient management plan? And then is it matching the requirements of the nutrient management plan? And if it's not, is there an adaptive management activity taking place so that we can massage some of these activities to try to make them more matching up, make them match up a little bit better? And this is the management component of that plan and that facility. And then we also may look at things like, the manure and process wastewater storage systems. And, we're looking at them for a little bit different thing this time. And it mainly are these systems delivering design capacity and ready for non-application season? So it's hard to follow your nutrient management plan if your nutrient storage structure doesn't have the capacity, wasn't emptied out completely enough the previous year and doesn't have capacity to hold nutrients for the non-application season. So again, we're looking back to those structural components to make sure that they're matching, because they're such an integral part of the system, they're matching everything else. All right, and so another thing that we would look at is the nutrient balance uh, and status at field level, nutrient application timing, and are application systems calibrated? And if nutrient export is part of their plan, is nutrient export occurring? And so the questions are, is the nutrient management plan as approved by our department, is it operating as it was designed? Do there need to be changes to that plan? Because we believe the nutrient management plan needs to be a living document. It needs to be flexible enough to change as the facility changes. And those things we look at as management components. And then we also would be looking at manure and process wastewater nutrient separation and treatment systems. And the question there is, are these systems delivering the designed nutrient removal capacity, and are the reclaimed nutrients in a form for export? So several farms, several of our permittees employ these systems because they don't have enough land and crop capacity to utilize the nutrients they generate, and they need to move those off the farm in a form that's easily exportable and can be utilized by other entities. So some of the inspections unfortunately result in enforcement, and we use a progressive approach that includes several levels. So from lowest to highest of water quality advisory, a notice of noncompliance, a civil penalty, and ultimately permit revocation if noncompliance is severe and serious enough, or severe and frequent. We would revoke their permit and not allow them to operate. And this provides regular contact, with permittees. We hope not as regular as the inspections for this activity, but we do several of these a year. The enforcement documentation provides required corrective actions, and some of those examples may be, we may be telling an individual permittee they have to limit total nitrogen application to no more than a certain number of pounds per acre per yield on a certain field or management unit. We may limit manure applications to none if phosphorus is a problem, and also limit any phosphorus from any other source to a certain field or management unit until the P index has a certain result or another milestone's met. We may require installation of moisture sensor arrays and limit hydraulic loading if it appears that there's over irrigation or too much liquid being applied that's forcing nutrients, below the root zone of the profile. And we may require sampling so many surface water locations for E. coli bacteria within a certain time of application to a field if we've seen repeated runoff discharges from that field in the past. And we would describe those all as management components. The enforcement, can require construction of manure and process wastewater systems, so we can do that under our permit. And we can also require proper operation and maintenance of those systems. If you have a system but you're not operating it correctly, it's not delivering that design water quality protections. And then ensure that systems are delivering their design storage capacity and that they're not discharging or imminently about to fail. And those are all structural components. This is an example of a notice of violation that we issued. It's pretty hard to read, so it's just for you to look at a later date. One example of how we would address some specific thing on a specific facility. So we also collaborate with our partners to help keep our staff up to date with the most current technology and science in nutrient management and in these structures. So we're looking at both of the management and structural components. We have an advisory committee that meets 3 times a year that helps advise us on how to operate the program and brings some of these new technologies to the table. We have industry associations, state and federal partners, the research universities and other academia, both technology and equipment suppliers, and then cross-media impact specialists. As these farms are a holistic operating activity, and to look at water quality, in a bubble without looking at the other impacts that a facility like this, may have, is probably not holistic enough. So we're trying to involve some of those thinkings. Some examples of our collaboration with partners are to expand nutrient application acres, by exporting to other cropping systems. And so sometimes the easiest way to move nutrients is just to physically pick them up and move them, sometimes in just normal liquid systems without a lot of treatment or separation. And by making those connections between other cropping systems and farming systems and our permitted CAFOs have been quite valuable in allowing the non-CAFO cropping systems to pick up on some of the manure magic, we call it, and there's been some great stories there. Also employ technology to provide data to assist management decisions. So sensors providing real-time data are been super helpful. Artificial intelligence and spatial data collection, and these are ever expanding fields that we want to pay attention to. And then to leverage sustainability issues like climate and other things that are coming down the road, that may be helpful to our permittees in managing some of the nutrients that they need to manage. All right, one more slide here, and that is my contact information at the department. And I think there'll be a time for questions here at the end. All right, thank you so much for your time, and look forward to responding to questions.